Children, let's see which substances are soluble and which substances are insoluble. Here see, water is an excellent solvent. Why? Because it allows so many substances in it. So, water is an excellent solvent, children. It's an excellent solvent. Solids plus water. Yes, solids dissolve in water. The best example is common salt. Children, you know that if you add salt to the water, the salt will dissolve. And if you taste the water, it will be salty. Am I right or wrong? Yes. So, solids are dissolving in water. Let's go for the second one, liquids plus water. Yes, alcohol. Alcohol is a liquid, liquid to liquid. In the previous example, solid plus liquid. In this example, liquid plus liquid. In the next example, gases plus water. Gases plus water. Yes, carbon dioxide dissolves in water. You get carbon dioxide plus water is soda. Okay, so air, sir, this is gas, dissolves in water, liquid dissolves in water, solid dissolves in water. That is why water is an excellent solvent. What is solvent? Which is taken more in quantity. So, these are called as soluble. So, what is soluble? Salt is soluble, alcohol is soluble, carbon dioxide is soluble. The substances which are mixed with water are called as soluble, which are not mixed with water are called insoluble. They are called as insoluble. Okay. Children, so far we have seen the solids like what? Yes, solids like salt or sugar dissolve in water. Liquids like alcohol dissolves in water. Gases like carbon dioxide dissolves in water. So, those are soluble. Now, let's go for the insoluble. Insoluble means which cannot mixes with water, which cannot dissolves in water. Many substances do not dissolve in water. Yes. For example, if you take oil, oils are usually insoluble. Oils are usually, they do not dissolve in water. That is why oils are usually insoluble. Soluble means dissolving, insoluble means they won't dissolve. Here say sometimes when oil and water, a mixture of, you see, a mixture of, when a mixture of oil and water is shaken, when you will shake, oil usually insoluble in water, but if you try to shake this oil plus water, you will get a solution called as emulsion. What is that, children? The resultant is emulsion. Usually oil won't dissolve in water, but if you try to shake oil and water, the result is emulsion. In the same way, some solids are insoluble. For example, here see, if an insoluble solid is mixed with water, if an insoluble solid is mixed with water, the resultant is suspension. What is suspension? Insoluble solid plus water is suspension. What is the difference between emulsion and suspension? Oil and water shaken is resultant is emulsion. Insoluble solid plus water, the resultant is suspension. Once again I repeat, some substances are dissolved in water, some substances do not dissolve in water. Like oil. Oil is insoluble in water. So here, but sometimes when you try to shake the oil and water, the resultant is emulsion. Insoluble solid plus water, the resultant is suspension. Okay. Children, so far we have seen solids and liquids. Solids have a fixed volume and a fixed shape. Liquids have a fixed volume but take the shape of the container. Notice gas. Gases have no fixed volume, no fixed shape, children. It is neither having a volume nor having a shape. Okay, right. Gases, very interesting thing is, they expand to fill all available space. Here see children, if you blow the balloon, it depends upon the gas you fill. It will become this much size, it will become this much size, it will become more, and if you go on blowing, it will burst. That means gases expand to fill all available space. Gases expand to fill all available space. Atoms in a gas are free to move independently from each other. Atoms in a gas are free to move independently. They won't stick to each other. They won't, here see, in gases, the molecules are very free and the space is also large when compared to solids and liquids. They move in a random direction. Random means there is no particular direction. They will go, okay, in a random, they move a random direction. The gaseous state is the simplest because the atoms in a gas are moving at random. The gaseous state is the simplest to describe mathematically. If you blow air in a balloon, it takes the shape of the balloon. Yes, I told you already. If you blow air in the balloon, it takes the shape of the balloon. So once again I repeat, the space between the gas molecules is very large when compared to solids and liquids. It has no fixed volume or no fixed shape, but gases expand to fill all available space. Atoms in a gas are free to move independently from each other. Because the atoms are moving in a random direction, the gaseous state is simplest to describe mathematically. If you blow air in a balloon, it takes the shape of the balloon. Children, can you give some examples for the gases? Yes, nitrogen, oxygen, carbon dioxide, all these are the gases. Okay, in our house, we cook with the help of a gas called as liquefied petroleum gas, LPG. LPG, liquefied petroleum gas, okay, which is made up of butane. Cooking gas is made up of butane. Okay, children, like this, gases do not have shape, gases do not have volume, the space between the gas particles is large, they move in a random direction. That is why it is easy to describe the gases in a simplest to describe mathematically. If you blow air into a balloon, what happens, children? It takes the shape of the balloon. Am I right or wrong? Yes. Children, now take page number 63. You have three states of matter and the pictures here. Solids, liquids, gases. What are those, children? Solids, liquids, gases. See the left hand side, these are the set of the solids. Hat. Hat, is it a solid or liquid or gas, children? Yes, solid. Skateboard. What is that? Solid. Table, I told you already, table, bench, solids. Pencil, which you write, also a solid. Cycle, bicycle is also a solid. Computer is an example for solid. The tree house is also a solid. Now in the center the liquids are there, children. Water in a pool, water is a liquid. Drink, any soft drink is a liquid. Milk is a liquid. Hot chocolate is a liquid. Drink is a liquid. Soup, children, do you like soups? Tomato soup or hot and sour, those are also liquids only. Juices like apple or a slice, okay, any tango, so that is comes under liquids. Rain is a liquid. Children, the last box consists of the gases. See here, wind is a gas, air is a gas, hot air balloon is here also a gas, wind from fan is also a gas. Wind is also a gas. So we can't see the gases, children, but we feel the air. We feel the gases, we can't see the gases. We can smell the gases, children. You can smell the perfume, but you can't see the perfume. Okay, you can't see the perfume. If you can see the perfume also in the form of liquid only, you can see that spray is there, no, that one. Okay, children, let's go for the change of state. Change of state means, yes, from solid to liquid, liquid to gas, again gas to solids. Okay, so this is called as change of state. Take page number 64. Everything in the world is made of matter. Yes, starting only I told, the benches you are sitting, the table, the wall, the board, human bodies, everything is made up of matter. Walls are made up of matter. Milk is made up of matter. Even air is made up of matter. See, in the first one, wall is made up of matter, that is a solid. Milk is made up of matter, that is liquid. Air is made up of matter, that is gas. So matter comes in three different states. Solids, here see, can be hard or soft. See children, this book is soft. But some solids, like trees, if you will touch, that is very hard. Okay, the tree stems if you will touch, that is very hard. So some solids are soft, some solids are hard. Wood is hard. Okay. So some solids can be hard or soft, keep their shape. They keep their shape until and unless you do something to change them. Here see children, this book is in the shape like this shape, this is permanent shape. If you try to, yes, if you try to bend, again it regain its shape. Okay. But if you do like this daily, yes, the shape will change. Until and unless if you apply pressure, okay, or if you apply temperature, sometimes they retain their shape like that only. Okay, children. So solids can be hard or soft. Keep their shape until and unless if you do something toward that. Next one, the shape of solids like clay are easily changed. That is called clay molding. During clay molding, what you will do? Yes, you can convert the clay into different shape. You can make Buddha, you can make Ganesh, you can make bangles, whatever the shape you can convert, you can convert. So the shape of clay are easily changed. But some substances like wood, we can't, it is not easy to change the shape. Yes, we can change the shape of the wood. After cutting, you have to do so many things. Understand? Right. So, solid like wood are much harder and not easy to change the shape. This is about the solids, children. Once again, I repeat, the changes of state. Solids can be hard or soft. Okay. They keep their shape like that only unless if you do something to that. Something means applying pressure, heating or cooling, whatever. And some solids can be changed easily like clay. You can, why? Because that's a soft one. But some substances like wood, you can't change. If you try to change also, you have to put so much effort on that. Understand? So here this is about the solids. What about the liquids then? Liquids cannot change their shape. Liquids actually no shape, first of all. Liquids do not have shape, and liquids occupy the volume of the container. Shape of the container also, children. Here see, if you pour a glass of water, what is the shape of the water? Very good, glass shape. But if the water spills, it will spread out. Children, this is a common experience that if you pour water in the glass, the water takes the shape of the glass. If it spills on the floor, it flows. Okay. Some liquids are thick, children. Some liquids are thick. Like, children, have you taken any time the cold milkshake? Have you drank the cold milkshake? That is very thick. Okay. So liquids are thick like cold milkshakes, and they are also even thin like apple juice. Apple juice is very thin. Cold milkshake is very thick. Okay. And here liquids can be very different from each other, but they all can be poured. Thick liquids or thin liquids, both can be poured into the bottle. Okay, once again I repeat, liquids, they do not have shape, but they take the shape of the container. If you all pour the water in the bottle, what happens here? Liquids takes the shape of the bottle. If you pour water in the glass, water takes the shape of the glass. If you spill the water on the floor, it flows. That means here liquids take the shape of the container. And next one, two types of thick liquids are there, children. One is thick, other one is thin. Best example for thick liquid is cold milkshake. Here best example for thin liquid is apple juice. What is that? Apple juice. Okay. Children, so far you have seen the solids, liquids. Now it is gases. You know that gases have, do they have shape, children? No, they don't have shape. Air is a gas, children. The best example of gas is air. Not only one gas, so many gases are present. I told you already, like oxygen, nitrogen, carbon dioxide, inert gases, all these are present, children. And like air, most gases are invisible. Invisible means we can't see. We cannot see, children. We cannot see the gases, but you can feel. See, you can feel air move against you. When you feel wind against your face, you are feeling a gas. So when you move against to the wind, your face, what do you feel? You feel the gas, but you can't see the gas. Air is all around us. Gases spread out to fill any container they are in. So gases also takes the shape of the container and even really big spaces also. Gases are easily compressible, children. That means you can compress the gas also. Okay. So once again I repeat, gases do not have shape. Air is a gas. Air is a mixture of gases. Like air, most of the gases are invisible. We can't see. But you can feel the air, children. You can feel the gases. For example, when you move opposite to the wind, you can feel the wind, the force of the wind on your face. And air is all around you. Gases spread out to fill any container they are in, even really big spaces also. Okay. Good morning, children. Now let's see page number 64. Yes, we have learnt the changes of state. That is three types of matter like solid, liquid and gas. So we have learned that solids are like wood are much harder and not easy to change the shape, whereas liquids have no shape. Gases also have no shape. Now in today's class we are going to learn about water and solutions. Here say, children, water is considered as universal solvent. Water is considered as universal solvent. Why? Because it can dissolve so many substances in it. So it is considered as universal solvent. And it is interesting type of matter, children. Why water is considered as interesting type of matter means it changes from one form to another form. It can change from liquid to gas. So water in the form of liquid is, yes, that is consumable for drinking, that is water. And its gas is vapor, children. So what happens here? When you boil the water for longer period of time, you can observe the steam which is called as vapor. So the conversion of liquid to gas, water to vapor on boiling. On boiling, here the conversion of liquid to gas, I mean water to vapor takes place, which is called as vaporization. Which is called as vaporization. Now, let's go for the second process, which is called as freezing. Children, you observe that you play with the ice cubes. What you will do? You just fill the ice tray with the water in the refrigerator and you will keep in the refrigerator. You fill the water in the tray and you will keep in the refrigerator. What happens after some time? Yes, you can observe the ice cubes. So, where the water went? The water is converted to solid. The water is converted to solid. So, this is ice, children. This is ice and this is water. So, which is called as freezing. On, here see, on cooling here. On cooling, when you keep the water in the refrigerator, in the form of ice it converts. So, which is called as freezing. Now, let us go for another one, melting. Children, you know that when you will bring the ice from the refrigerator and you will keep at room temperature, when you will bring the ice from the refrigerator and when you will keep in the room temperature, after some time you see that ice starts slowly converting into water. So, here that is called as melting. Ice converts to water, which is called as melting. So, this is also a rise in temperature. This is also rise in temperature. Children, once again I repeat, water is an interesting type of matter. It changes from one form of matter to another form of matter. So, on boiling, the liquid, I mean the water is converted to steam, which is called as vaporization. On cooling, when you will keep the water in the refrigerator, in the deep freeze, you can see the ice. That is called as freezing. When you will bring the ice from the refrigerator and keep outside for some time, you see that ice converted to water, which is called as melting. Okay. See children, next one, you can see water vapor turn back into the liquid. This is a very interesting thing. See, water vapor turn back into liquid. Water vapor turn back into liquid. Now, let us see how this happens. Okay.